Hello everyone, welcome back to my YouTube channel Techno Dev with Saurabh. Today I am going to show one video which related to the Python and Redshift. So we are creating the cluster by using the Python into the Jupyter notebook, and we are creating the cluster and also creating the security group, subnet group which needed for the Redshift cluster very well, and we are upload the data using the copy command into the Redshift cluster from S3 bucket. And after all this, we are also watch the cleaning activity in this video, like dropping the tables, subnet group and security group. So this video is really important, and in this tutorial you see all the operations related to the Redshift cluster by using the Python. So you need to install some library which you used in this video. So that library is Boto3 and PG800, Psycop-G2, Pandas and pip. So by using pip you need to install this 4 libraries, and PG800 and Psycop-G2. These two libraries basically used to connect with the Redshift cluster. You can use any one of this library, PG8000 and Psycop-G2. In this tutorial I can show both library. By using the both library I am creating the table in the Redshift. So let's start the video. So first part, you should have the access key and secret key to connect with the Redshift, by using the Python, and from this access key we just apply all the operations. And you should have some VPC ID. So this is my default VPC. I can show you here as well. So you can go to the VPC, and here is a VPC. This is my default VPC. So this is my default VPC, and I use the same VPC ID here. Apart from that, all the things we are creating by using our Jupyter notebook. So first we need to create the security group by passing the VPC ID and group name. So group name is a description, like any description you want to give. My Redshift security group, I give it. And description, in description also you can pass anything like which you can understand, like why you are creating the security group. So I give security group for Redshift cluster access. And now first we are creating the EC2 client by using the Boto3 method and passing the EC2. So by using the Boto3 we are able to connect with the EC2 in the AWS, and after that we are creating the security group. Create security group method in this EC2 client, and this create a security group. We are passing the group name which I given here, my Redshift security group, and group description. You can pass any value in the group name, group description, and VPC ID, that is the mandatory, and this value I already specify in the upper cell. You can see this default VPC ID. So I have passing this all field, and after that the security group ID is created. So this method is used to create the security group. And why we are creating the security group? When we are creating the Redshift cluster, we need to attach one security group which allow the port, 5439 port. We will see later all these things. So I have created the security group and then print the security group ID, and after that we just exception handling, checking that this security group already exists or not. So we are checking the response like invalid group dot duplicate. If this method, this error comes and the response matches with this error, it means the security group already exists. So that's the message. Just in the exception handling we are handling this thing, like if this security group already exists, then we just say print the message, okay, security group already exists using existing security group ID, and return the security group ID. And if it is this security group not exist, then it will create the security group. So I just try to execute this whole scenario. So once I execute, so you can see the security group ID. So it created one security group, right? And value assigned into this variable security group ID. So this security group ID we are using later. So we are able to get the security group ID. And you don't need to worry users, I will provide the code in my Git so you can easily get from that and try to understand. And now come to the second part. Here we are creating the inbound rule for the security group. As I told you, like we need to allow the port 5439. So this is the default port for the Redshift cluster, and by using this port we are only able to connect with the Redshift. So the security group which we already created, we need to allow this port and IP range. Either you can provide your system IP in which you are testing, you can provide any IP, means anywhere, from anywhere you can connect to this port. So you need to assign one inbound rule. So I just use the authorized security group ingress method. So it is also the method of EC2 client. So first, using the Boto3, I connect with the EC2, and after connecting with the EC2 I just use the method authorized security group ingress. In this method we are passing the security group ID. That group ID I already fetch above, so this variable contains the security group ID. And after that I pass the protocol, that is TCP, from port and to port, that is also the 5439 value which we allow. And IP ranges, we are passing IP ranges here all anywhere. 0.0 means from anywhere in this security group, and traffic come to our cluster. So that's why we are creating this security group, and we are handling also the error. So that is the botoclear.exception. By using this we are handling the error well, and you can see here like this is the response we are getting. And if any error comes, then e.response error code. So into this it's check like if invalid permission dot duplicate, it means this security group inbound rule already exists. So if it is already exists, then you get the message inbound rule already exists for a specified port and IP ranges. Otherwise you are not getting any error, or if you are getting any error, then it will be print in the else part. Right, so we are executing this code as well. So let's execute it. So once now we execute it, and you can see, right, this is the inbound rule added to the security group, and also print the security group ID. That is also the same, right? This is the security group which we created, then we insert the inbound rule in this security group, and you can see the security group ID and inbound rule. And after that we just need to check the number of VPC and subnet. So what about my all default VPC ID? I already applied my VPC ID above. I declared it in the beginning. So from that there we are passing the VPC ID in the subnet, and we are using EC2 client and connect with the EC2 by passing the access key and secret key which I initialized in the beginning, and then I just describe the subnet. So when I use describe subnet, it print all the subnet of the EC2. So EC2, it means in the EC2 instance all the subnet you can see in the management console as well. So when I go to EC2, right, so in the EC2 you can see there is a no instance running, right, and now we can go to the subnet and VPC as well. So okay, now you can go to the VPC. Yeah, this is the VPC. So in VPC you can see the subnet and VPC ID. So all these things we are trying to describe. So the default subnet, and this is my default subnet ID, right, and this is my VPC ID. So all these things we just need to describe here. So it print all the all subnet of default VPC. So describe subnet and EC2 client response, and in the from the response we are fetching by using the for loop, and we are fetching the single values like subnet ID and subnet VPC ID, this subnet. So this is a variable in the for loop, and by using this variable we are passing all this value, and this in the dictionary all this value we are fetching to the variable VPC ID. So it print it. So I already execute. Now I am executing again in front of you, so you can see like this is the subnet ID, VPC ID, and this is the block CIDR block, availability John, South 1C, 1B, 1A. So it print all these three subnet ID, right, which currently exist in my system for default VPC. And the inbound rule which I created here, right above, I created inbound rule and security group. I can show you that as well, that already created, and you can see here. So if I go to the security group into the EC2 instance, you can see. So that is the security group which we created by the Python shell, and you know the inbound rule, you can see the inbound rule as well, right? This is inbound rule created by our program, right? No, so just cancel it. We are not doing any change here. So now back to the window, and okay, now our inbound rule order created successfully. VPC subnet we also printed. Now that operation is we need to create subnet group, right? So why we need a subnet group? Because we attach this subnet group with our Redshift cluster. So in subnet group, actually we are passing the number of subnet. As you know, right? Subnet is required for high availability and more scalability, right? So we are attaching multiple subnet. You can assign 1, 2 subnet as well, whatever subnet you have. So we need to create one group of all the subnet. Then we are attaching to the Redshift cluster. Okay, so that is you can see, right? Boto3.client we are using and connect to the Redshift. Right, and after connecting to the Redshift, that is the Redshift client, and after creating the Redshift client, so we are just passing the subnet group name. So that is the my subnet group, and the name which I given, you can give any name here, and we are giving the subnet ID as well. So all the subnet ID you can see, right, the above in this output we have the subnet ID print here. So all the subnet ID I just taken from here. You can assign into the variable and then you can do, but I just copy from here this value. So this all subnet ID I pasted here. So I created a list of all subnet ID which I want to create the group of this subnet ID, and group name is my subnet group, right? So that is the group name. And in the Redshift client I just use the create subnet group. So for this Redshift, right, for Redshift we are creating, remember that I am connecting with the Redshift. So currently we didn't create the Redshift cluster. We have not created the Redshift cluster, but before that we need to create the subnet group for the Redshift. So first we connect with the Redshift and create the client Redshift client. So now it by using this Redshift client we are calling the method create cluster subnet group. So in this method we can pass the subnet group name. So what is the subnet group name? I use the my subnet group. So that subnet group name passes here, and in the description what you want, what suitable with your requirement, you can give the description. And in the subnet ID, all these three subnet, right, list of this is subnet, we are passing in the subnet ID line number 24. And after that we just printing the subnet group name again, and this subnet group created successfully for Redshift. Remember this is for Redshift, and we can delete later also. So first we create it, right, and in the error handling we are just checking this subnet group already exists or not. If it is already exists with the name my subnet group, so we are getting the error. Okay, so just we are executing again here. Yeah, so it give the message subnet group created successfully, and that is my subnet group. This is the subnet group name, my subnet group, right? And this my subnet group we are using later. And now it's time to define the cluster parameter. Like we are creating the cluster, so we need to pass the parameter like what like the configuration of the CPU, right? Node type. So I am creating the cluster one node, so only one node cluster I am creating. So The important parameter I passing here, like cluster identifier. So this is the name of the cluster which identify to the cluster, and by using this cluster identifier we can apply later more operations. So you just remember, like, we are passing my Redshift cluster. So this is the name of the cluster, and we can say this is a cluster identifier, like by which we identify the cluster. And node type we are passing here dc2.large. So it's a minimum requirement. We are just doing some kind of POC in our local, so we can just take the less expensive node type, so it is a very less charge, so that you don't need to pay much charge. So we are using here dc2.large, and master username whatever you want to give, and make sure in the small letter, otherwise you will get error. And master user password, I have passing password 13. And DB name, my database, cluster type, a single node cluster, and number of node only one, so that's why it's a single node cluster. And publicly accessible, that flag we need to true, so that you make to sure always publicly accessible make flag you need to do true, otherwise you will not able to connect with the Redshift cluster using your Python Jupyter notebook. And we are use then VPC security group ID. So that security group I already created, right? This security group ID I created above, right? And in this variable, this security group, right, this security group ID are already created, and this value come to this this variable, yeah, security group ID. So in this security group ID I created above, here I created, right? And we are fetching the security group ID inside this variable. So I am using this variable into the cluster parameter. So I just repeating it so you not confused here. And I am passing the security group ID here. Availability zone, I am taking AP South 1A. So the primary created on this specified availability zone, I use the Mumbai region. And the port is 5439, so that is the port used for the Redshift, and this is the value we need to give. And after that, cluster subnet group name, right? This variable subnet group name, which we also created above. So this subnet group name and security group ID we created above, and these both variable required to create the cluster in the Redshift, right? So just go down and now come to the point we need to create the cluster on the Redshift. So we are using the Boto3 client again, connect to the Redshift, right? And after connecting you to the Redshift, we are use the method create cluster Redshift client dot create cluster, and passing all the parameter by using this cluster parameter. So see, right, cluster parameter I define above, and in this all parameter apply to the cluster, right? So you can see here create cluster method, and I'm passing the cluster parameter. So Redshift client dot assertion dot cluster already exists. So it checking if this cluster already exists. So it give error cluster already exists and skipping cluster creation method, right? So first it try to create the cluster, and if it is already exist means the parameter which we are passing, right? So there is a cluster identifier I am given here. So if I created a first time and again same time I'm passing the same configuration and the same name, right? Cluster identifier same. So it would give the message like it already exists. Yeah, but we can create, like, by changing the cluster identifier, we can create again cluster with the different name. So you just I think you are getting the point, right? So we just create the cluster, we are passing the parameter here and exception handling. And after that, it's a very important method get waiter. This is also the method of Redshift client, and we are using get waiter method. So what you do? So this method actually wait till this cluster is not available, because when we create the cluster, it would take some time. around 2-3 minute, might be 4 minute, right? So you need to wait. So this method is actually just in the loop and waiting. This method not return anything and just in the loop and waiting till cluster not available. Once cluster the available, it give the this line, the control comes down and print this line, Redshift cluster is now available, right? So I just try to execute it again, and first this initiated, so cluster creation initiated, but cluster is not created, right? You can see this code is still running, there is a star. So if in the Jupyter notebook you can see in the star in this bracket, it means this block is currently running, it's not executed completely. So when it executed completely, when this method redshift client dot get waiter, when it written like cluster is available, then only it comes to print this line, right? Cluster is now available. And you can see also in the Amazon Redshift by the management console, so cluster request is initiated and it would take some time. Okay, so let's see. Yeah, you can see, right, total node and one node, and it is in progress. Now come down and yeah, so it is in progress. My Redshift cluster, you can see name, right? So it is in progress, status is creating. Once it's available, then you can apply the operation like creating table and inserting data, copy data. So we can see that thing going forward. So currently we need to wait here, so just wait for some time. Now you can see the message come here, Redshift cluster is now available. So it means our cluster has been created successfully and it's now available. And you can see here in the Redshift, and just refresh it, and it's still in progress here. So just we just do here, refresh it in the browser also. It's show unavailable. We just wait few minutes also. Like it shows CPU utilization 72%. Let's wait few minutes. So here we can see like our this method is executed successfully, but also our this when we check into the console, it show like cluster is unavailable. So we try to attach the IAM role as well. Let's see going forward what happened. So the IAM role we already created. I already created my Redshift for test this role, and this role have the permission for access the S3 in the Redshift. So this role I need to attach. I can show you this role as well in the IAM window. So just go to IAM here. So in the IAM, I already created that role. We only need to attach with the cluster. So go to the role and went to this my new Redshift for test, and I just attach, give the permission to the Redshift, and this permission Amazon S3 full access. So just go to the code, and I am just fetching the role ARN, this ARN number for this role, my new Redshift for test. So after fetching this and this ARN, we are just trying to attach with the our cluster. So this cluster ARM modify underscore cluster underscore IAM underscore role. So this method, this is also we are using for Redshift client. So Redshift client, like this, we first create the Redshift client, right? And I just paste here so that you not confused. So Redshift client, we just using this method modify cluster and assign the cluster identifier. And what the cluster identifier? So in cluster parameter we assign this value cluster identifier, we can see above as well. So in this cluster parameter dictionary you can see the cluster identifier is a key and its value is my Redshift cluster. So this value required, right? So that's why we are in the cluster parameter, I just use this cluster identifier. So my Redshift cluster, the value come here and creating the IAM role, and I'm also passing the role ARN, this ARN, so that I can access S3 bucket into the Redshift. So try to assign. So this role will be granted to access S3 within the cluster. So I think this role assign, and we can check again here. I think it show still unavailable. And we can see property as well here. So in the property you can see, right, the database name, port name, and this is the admin username, and this is a virtual private key and VPC, and this is subnet group, my subnet group we are attached here, and this is the availability zone, and this is a security group, and public accessible enabled. And also you can see associated IAM role. So this IAM role also associate here, right? Everything is looking fine. So we can try to open also, right? We can go to query editor here and we try to open this cluster as well. So you can see, right, this cluster already open, and that is that all the credential my database, we created my database, you can see here. So that is the my database we actually try to create. So all this thing is created, but I'm surprised like why it is showing, you know, unavailable. Still it's showing unavailable, but our cluster created successfully. Now it's available. Now it's status change. I think something I did mistake by refreshing. Yeah, it will take some time because I executed this code multiple times before this video as well. So might be it would take some time, right? So yeah, but now it's cluster available, but in the code it's available before, but might be I didn't refresh, you know. Yeah, something happened. Okay, now go to the code, and you just able to understand, right? I have attached the IAM role here, and this IAM role give the permission to access bucket into the Redshift, so that we can upload the data from our bucket into the Redshift. That's why I assign this permission, this role. So this role I created already my new Redshift for test by manually, and after getting the role ARN and assign this role here. So okay, now come to the this block, and here we just describe the cluster, means we just want to information of all the cluster. So again we are using the Redshift client, so I just print here also, and you can see, right, again I am using the Redshift client, and by using the Boto3 I connecting to the Redshift and describe the cluster. So I am just passing the identifier. The identifier means name, my Redshift cluster, this is the name, and print the information here. I can execute again. Yeah, you can see, right, this is the identifier and node type, all the cluster status available, and the port, everything you can see, right? Availability John. So all the information related to cluster print here. Now come to the important point. We have the cluster we created here. Now we just want to create the table into the our Redshift cluster. So we have the two library, PG8000 and psycopg2. Both Python library used for interacting with PostgreSQL database, including Amazon Redshift. So PG8000 is a lightweight and pure Python PostgreSQL adapter that aims for simplicity and ease of use. So we can use easily this library PG8000, and it is a lightweight. And psycopg is known for its performance basically, and its preferred choice for high performance database interaction. So I just give you both example by using the PG8000 and psycopg2. So PG8000 I imported here. So make sure you need to install, I am using the Anaconda. So in the Anaconda window you can see here, I just use the command pip install boto3, right? And pip install PG8000 and also pip install psycopg. So all this library you need to install before importing, right? So I import PG8000 and this is the Redshift endpoint. So this information from where I got, so you can see also in the Redshift cluster. When you go to the Redshift cluster, you can see the JDBC endpoint. So endpoint, right? This information we are using to connect with the cluster and create the table. So if you don't want to go to the management console, in this itself you can check here when I describe the cluster, right? Cluster information. So it give all information. So you can see here all the information like cluster name ARN, right? This ARN. So you can see. So all the information here you can take from here as well, and as well as you can take from this endpoint here, just copy from here also, right? So same ARN we need to pass here. So I just copy in front of you, just Control V, not this one, sorry, I just need to property, and so we can use this endpoint. We try to use this endpoint, right? So where it is, yeah, so this endpoint. So actually we don't need to pass the my database and 5439, we are passing below. So this is the Redshift endpoint till com and .com, and we are passing Redshift port below 5439. Redshift user, my AWS user, this is the password, and Redshift database product table. So this table we want to create, right? Product table. I will provide all this script into the Git, so you don't need to worry about it. And this all configuration, port, user, password and database, we already pass in the cluster parameter when we created this Redshift cluster. From there we pick this value, and after passing this value we try to connect using the PG8000 library, PG8000 library dot connect method, and passing all this information, port, database, user, password, and open the cursor. So by using this method we just connect to the Redshift and open the cursor in the Redshift and execute this create command. So this create table actually check if this table not exist by the name product table. So it create this table which contain this column marketplace, customer ID, product ID, seller ID, sale data, quantity. So this table we created, and after that we just use the execute method, cursor dot execute. So and in this method we pass the create table command. So cursor dot execute method actually just execute this create table, and we already open the cursor and then we execute it, and passing this create table command and create the table and commit it. So if it get exception, we handle exception as well, right? And after that we close the cursor and close the connection. So just execute here again and let go up. Yeah, so product table created successfully, printed, right? So this table is actually created in the backend, and now we are need to insert the data, right? So I am using again pg8000 library, right? And by using this, we connecting to the Redshift, passing all this variable which I declared, right? And by using this variable, I open the cursor, and this is my bucket, my glue ETL project. So inside this bucket, this bucket, my Python project, right? My Python project. So in this bucket, there is a folder input and file product data.csv, which I already uploaded. I can show you. And we just go to the bucket, and so you make sure you created into the same region. I created into the Mumbai region, and in this my Python project one, and in this input folder there is a two file, product data.csv and emp.txt, right? The two file I can show you here also. This is the emp.txt, right? And there is only 3 rows, right? And 3 column, emp id, name, salary, and second one is product data.csv. So these two table we try to create and upload this data, right? So now come to below point, and now go to this, and I am just using copy command and give public dot. So by default, whatever table we created, whatever tables we created, so it create on the public schema. So I use the public dot. So if you don't use the public dot, it would create into the public schema, right? So I just use public dot, and this is the product table which I created above by using this pg8000 library, and this is the bucket location from where this file product data copy into this product table, right? And in the credential access key, secret key, which I already described above, and delimiter is comma separated. This is the CSV file, and ignore header. So first record, which is header, ignored, so that would not inserted into our table, right? And then again this cursor we need to execute, cursor.execute copy command. This command we are executing inside the cursor. So we are open the cursor, right, from connecting to this pg8000. By the help of this library we connect to the Redshift, and by using this connection we open the cursor, right? So in cursor we execute the copy command and then commit, and also handle the exception, and below I just close the cursor and connection both, right? And now I execute again in front of you, just go up. So okay, now it show copy command executed successfully. It didn't give any error, so it means the data is going to the product data table successfully. So you don't need to worry, I will show the data also by using same. And now come to the psycopg2. So by using the pg8000 we create the table and upload the data, and same we doing by using the psycopg2, same method, all the things are same, only this we are importing psycopg and connecting by using the psycopg instead of p8000. So we connected with the psycopg and passing this all parameter or host, port, database, user, password, and open the cursor and passing this command create table. If not exist, emp. If table not exist, then it would create. Otherwise, if it is exist, it will not create. So this table we are creating, right, and executing inside the cursor.execute and passing this create table command. And below we are handling the error, and just close the cursor and connection. So just execute in front of you again. And now it's show the message create table successfully created and already exists, right? And after that creating the table, we are using the psycopg library. So this library is actually, again we are inserting the data, copy the data, right? So connect to the Redshift and then open the cursor, and again this emp table, we are just uploading the data from this file emp.txt into the emp table, right? Credential we are passing, which I declared above, and delimiter is comma, and ignore header is 1, so we are ignoring the header, right? And again we are executing cursor.execute method, copy command con.commit, and execute this copy command, then commit the connection, and then just close the cursor and close the connection. So we are just copying the data, right? And in which table? emp, and try to execute, right? And it go to the next cell, so just we need to go above again and check the message. Okay, so it gives the error, right? You can see load the table emp failed, check stl load error. So it's a very important. So this table is actually exist into the Redshift, and in this table the error which coming in above block, right, in which we are trying to copy the data into the emp table, employee table, emp table. So that error capture inside this table, stl load error, and this table inside the Redshift. So we need to query this table and fetch what error coming, right? So come down and we again try to connect with the Redshift by using psycopg. You can also use the ps800 library, and after connecting with the Redshift, and we just open the cursor and passing this query, select star from stl load error. So this table is actually exist in the Redshift, and it captured the error, right? And then we just, after executing using the cursor, we fetch all detail. So cursor dot fetch all, and print the error using the for loop. So it show the error in very unformatted, so that is not formatting way to check the error. So it's difficult to understand this print error message, right? And we just close the connection. So that's why what we did here, we try to create the pandas data frame. So by creating the data frame, that error message we can visually see in better way, in formatted way. So come down and you can see the pd.data frame. So that library pandas I import above, right? This import pandas as pd. So same library is panda pd.data frame method, and I am passing here load error. Load error means the fetch, this method cursor.fetch all. So all the error, like the table, this table written all the data, that fetch by this load error variable. So inside this variable I just use comma and column. So this load error I am passing into the data frame because that is comma separated error, and also we need to fetch the column. So that column part we are fetching like this. So in this cursor actually dot description, so fetch all only give the data, but dot description method give the column name as well. So we are fetching this for desk, this is our parameter and variable in cursor dot description, and it written the columns. So all that we are trying to fetch all the column of that data, this table data, and try to create the data frame, and using the display method also. So make sure use the display and passing the df. So you can see the panda data frames in a very good shape, and try to execute it. So let's move above. So you can see this is the method, this is output. You can see this is unformatted way, and why this error comes like this way, because we are using for loop and this printing like this way. But we are creating also into the data frame, and then we are displaying here. So you can see in the table format, and it's look very well, right? And this is the actually this table stl load error table, right? Data. So in this table you can see all the things like why the error coming here. So the column name, employee ID, all the things are available, data and all this thing. And you can see delimiter not found. Yeah, so this is the error region, delimiter not found. Why delimiter not found? Because when I upload the data, right here I upload the data, In which table? In emp.txt, right? And in this emp table, by using this file emp.txt, so this file is actually pipe separated, but what I use the delimiter here, comma, so that's why it gave the error. So come down and we try to execute again and correcting it. So I just put here pipe instead of comma, and same code we are trying to execute. So why I did this way, so that you can understand the importance of this table stl load error, right? How can you identify the error while loading the data? So just we trying to copy again. Now it executed and it give message copy command executed successfully. So now it inserted the data into the emp table as well, this public.emp, right? So now we have the data in the emp table as well as product table, right? Both thing we already seen, and we have used all the two library psycopg and ps8000, right? So now come to down, and now we just try to fetch the data from the emp table. So again I am connecting to the Redshift by using the psycopg, and I try to run this query into the connection, this Redshift, select star from emp. So it should return the data, right? Because we already inserted by using our file, pipe separated file, right? And try to fetch all, cursor.fetch all, and then I print the row by using the for loop and close the connection. So just execute again and let's see. Yeah, so it showed the data, right? This is the data I actually inserted by uploading the file into the Redshift cluster. So you can see all this data. So it means our data inserted successfully into the cluster, and we can see data by connecting to the cluster. I fetch the data. And same we can use the product table, all the things are same, just connecting to the Redshift and fetch all the data by using the cursor, then use the for loop and close the connection, cursor both, right? And just execute it. So you can see this product table data as well, right? So our copy command is executed successfully, that we can see that also, like we can also see the data. And after that, now our cleaning activity will start, right? Now we created the cluster subnet group. First we create the security group, then subnet group, inbound role, and create the cluster and create the table on that using both library, right? psycopg ps pg8000, and you can see the way we are just inserting the data and also query the data. Now we need to clean the tables, drop the table and drop the cluster, and delete the subnet group and security group. We just want our system again clean like before. So right, cluster is very expensive as well, so we don't waste time more, and just okay, we drop the table. So I am taking the list of emp and product table. I am dropping this both table and connecting again to the by using psycopg we connect with the Redshift, open the cursor, and I use the for loop. So because in my list two table, right, I'm creating in a once, so I'm using table name and applying into the list, and in this looping just it passing one by one the table name, and in this variable first value come emp, then product table, and then it executed two times, right? cur.execute and drop table. And once it successfully dropped, then we again commit the connection and close it, right? And just run it. Okay, it dropped successfully, right? So now we are not able to fetch the data. Okay, I go above, and now if I try to fetch the product table data again, so it should give error, right? Now it should look, see, it give the error, data not exist, right? Because we drop the table, both table emp and product table. So now you are not able to query the table from Redshift. And once you done, delete your Redshift cluster, right? Once you drop the table, now I am deleting my cluster. So there is a method delete cluster. So now I am using the Boto3 library, connect with the Redshift and give the cluster name my Redshift cluster. You remember this is the same identifier we are passing when we create the cluster, right, in the parameter. So same identifier I am passing here. So by using this identifier, it uniquely identify the cluster and it would delete. And one important point is I just use skip final cluster snapshot equal to true. So make sure you put true. So why we are putting true here? See, because when we are deleting the cluster, Redshift asks for the snapshot, means backup. So whatever you already did into the cluster, Redshift asks you want to take the backup or not. If you are taking the backup, so it would take the long process, right? And that backup you can use later if you are creating the cluster again. So you can use that backup, right? But we are using just for the POC purpose, right, in development environment. So we don't need that backup, right? And we are not using the table in the future again. We just do the practice from our side. So that's why we just use skip final cluster snapshot equal to true. It means it would not take the snapshot, it would not create the backup of the cluster, right? And it deleted successfully in the right. So and once when it deleting the cluster, there is a one more method, get waiter. We use this method earlier as well when we are creating the cluster. So again we are using the get waiter, get underscore waiter method. So this method is actually wait till this cluster deleted successfully, and it is a loop, right? So this message only print when this cluster deleted successfully. It would also take some time. Now execute it and it would take time, right? So you can see that is the star in the bracket, so it is in running, and this print statement also not showing any output. So just we need to wait few minutes. So you can see message now delete cluster successfully, right? So it means now our cluster deleted successfully. And now come to down, and now we need to create the subnet, delete the subnet group, right? We created subnet group and security group. Now we need to delete it because now it's not any requirement of this subnet group. We are just creating the Redshift. So okay, we're just deleting here. So we connect with the Redshift first by using the Boto3, and there is a method delete cluster subnet group, and inside this method we are passing this subnet group name variable. So in this variable there is a value which we already assign above while creating the subnet group. So same variable we are using here. So this subnet group name would delete it, right? So just execute. Okay, so now it's give the status code 200. It means that our request was successful and it deleted subnet group successfully, right? Now come to the deleted security group ID. So again same method, like we are connecting to with the EC2 client, right? So EC2 client, right? We above also created, I can show you again, EC2 client, we have created somewhere, right? EC2 client. Yep. So you can see here, right? We just connect with the EC2 by using the Boto3. So same we are down, go to down, scroll down. Yep. So here we are connecting with the EC2, right? So we just by using the Boto3 we connect with the EC2 and delete the security group, and we are passing the security group ID as well. So this security group variable, this security group ID variable contain the security group which we created above. And now when we execute again, you see this message HTTP status code 200. It means our security group deleted successfully. right? So our this is the cleaning activity. So I think you understand how we connect with the Redshift, how to create the cluster, how upload the data. And I am using both library, psychopg and pg at 000. So I think you like this video. I will also provide all this code. So if you like this video, please subscribe my channel, and if you want any help, you can just give me your query in my WhatsApp number. Also you can ping me, also you can comment me on the YouTube channel. So thanks for watching my video. Have a nice day.